We are given y equals 3t to the fourth and asked to use the limit definition of the derivative to find dy dt. Recall that the limit definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. In our case, we'll be using t instead of x. So let's see. So y prime is the limit as h goes to 0 of f of t plus h. So 3t plus h to the fourth minus 3t to the fourth all over h. So this first one here, f of t plus h, note that I just replaced t with parentheses t plus h, right? And this one over here, 3 to the fourth, is simply f of t. Okay. The question now becomes, how do we expand t plus h to the fourth? And you could certainly do this out, right, like this, and do this very long algebraic, manipulation. What I'm going to do here instead is use Pascal's triangle, because this is a binomial, right, two terms, and Pascal's triangle is useful for this. And it goes like this. So I'm just going to start it here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. What am I doing? I am, for each layer below, I'm adding the two diagonals above the slot in this triangle. So 3, I added 1 plus 2. I added 1 plus 2 plus 1 for the other 3. Here down at 6, I added 3 plus 3. 4, I added 1 plus 3. This gives us the coefficients for binomial expansions. So this top one here is a plus b to the 0. It's just 1. Nothing really is going on there. Second one, a plus b to the 1. Right? It's 1 and 1. Here's one we recognize, a plus b squared. Right? Because we know a plus b squared is 1a squared plus 2ab plus 1b squared. 1, 2, 1. That's how these coefficients work. So here things start to get interesting. We pretty much already knew everything up to this point. A plus b cubed is this one. And I honestly just recommend memorizing these coefficients for a plus b cubed. It comes up enough and it's easy enough to memorize 1, 3, 3, 1 that it's going to be a useful thing to have on ready recall. So I've always said memorize that because you see a plus b cubed often enough, especially in a course like calculus. Finally, what we're interested in here is a plus b to the fourth. These are the coefficients. So what this means is t plus h to the fourth. So we grab this coefficient, so it's 1, and then it's all t, so t to the fourth. And then plus 4, the t's go down 1. I can already tell that this isn't going to be enough room. Let's try this. Yeah, these binomial things take up a lot of space. Okay, the t's go down 1 power, and the h's go up 1. So 4t cubed h. Plus, now we grab the next coefficient, 6. The t's go down 1, t squared. H's go up 1, h squared. Plus, grab the next coefficient, 4. T's go down 1, t. H's go up 1, h cubed. Plus, grab the next coefficient, 1. So 1 times h, I guess we'll put a 1 here, to the fourth. Now it's all h's. So it started out all t's, the t's went down, the h's went up, and here we have an expansion of t plus h to the fourth using Pascal's triangle. So going back to the limit, then we have, so y prime then is the limit as h goes to 0 of 3 times all of this, t to the fourth, plus 4t cubed h, plus 6t squared h squared, plus 4 th cubed, plus h to the fourth, minus 3t to the fourth, all over h. all over h. And our goal is to get this h in the denominator to cancel out with something, because we don't want to divide by 0 as we let this limit approach 0. Okay, well, right off the bat, we have some pretty nice cancellation. Look, this is 3t to the fourth here, which cancels with 3 to the fourth, negative 3 to the fourth. 3t to the fourth cancels with negative 3t to the fourth. Right, so right away we've gotten rid of something. But now note that this 3 still has to multiply through to all these terms. So let's clean this up a little bit. So y prime is the limit as h goes to 0. And now we have, let's see, 12t cubed h plus 18t squared h squared plus 12t h cubed plus 3h to the fourth, again all over h. And now we can cancel out the h's in all of these. Each one of these has an h in it. So here the h's just cancel. Here it would cancel with one of these, leaving h to the 1. This would become h squared. This would become h cubed. And we have finally gotten rid of that h in the denominator. So this is a good sign. Keep going. So we have the limit. H goes to 0 of what's left, 12t cubed plus 18t squared h plus 12th squared plus 3h cubed. And then when we run this h in the denominator, or this limit h to 0, we essentially plug in 0 for all these h's. So this goes out, this goes out, this goes out, and our final answer is 12t cubed. That is our derivative, y prime. If nothing else, this helps us appreciate what we'll learn eventually is called the power rule. So this took us, I don't know, a few minutes, but just to demonstrate the power rule, so we had y equals 3t to the fourth. What the power rule tells us is that y prime, you just bring this down and multiply, and subtract 1 from the exponent. So 12t to the 4 minus 1 is 3. Done. Okay, so you can imagine once you're proficient with the power rule, it's going to take you literally about 1 second to do the power rule versus several minutes using the limit definition. So the rules of differentiation save a lot of time once you start using them.